All right. So, for those of you who haven't seen me before, my name is Rocky. I do work for Microsoft. For those of you who have seen me before, I'm an architect advisor, right? No longer says security advisor. I shifted roles in November, and I get to stay home a lot more now. I don't have to deal with those phone calls at 2 in the morning saying, come help me, we just got hacked, which is good. The wife likes that better. This session is more about architecting applications and doing it to handle data protection or to handle data sensitivity issues. One of the things I get a lot when working in Canberra, when you talk about doing cloud anything in Canberra, is data sovereignty. Sorry, can't do it. We're going to talk a bit about that. Are you sure? Nobody said you couldn't do it, but you know. So there's a couple of people in here in speaker shirts, 2 of us. I finally figured out why they're this color. It's so we can hide against the wall and you can't see us. But it only works in this room. It's cool. Okay. Some of the things I want to talk to you a bit about today with this idea of hybrid architectures in the cloud. What's the problem? Why do we need something like this? What the hell is a hybrid architecture? And why are we considering this? Why is this even something we have to have, right? So there's a couple of misconceptions I want to clear up about the cloud being all or nothing, how you can deal with that, and how we deal with data sovereignty, because that's usually the big blocker, right? So there's 3 or 4 things you get when you talk about taking advantage of cloud. You get security, data sovereignty, and I don't trust you, right? There's a lot of FUD around moving things to the cloud or taking advantage of cloud services. And we want to look at some of that and how we address it in a sane manner. For those of you who came in late that do know me, no, it is not a hacking session. I'll try to do that later. How do we address this problem? How do we take care of these issues where we may see a great cost savings by taking advantage of cloud computing, but if we have a data sovereignty issue or we have a Privacy Act issue, how do we have the mechanisms to take care of that? What is the hybrid architecture that we want to use? And then the challenges with a hybrid architecture. Latency, right? The speed of light's not going to change for some time yet, but it's still a finite number, right? Do any of you in here work for a government organization, state, federal, or public sector? Okay, cool. How many of you work with government organizations? Most of you. Is there anybody in here that's just thought this would be a nice, empty, cool room? Okay, all right. I want to make sure there's not too many tourists. I like tourists. We're all tourists here this week. Have you guys looked at cloud? Have you come across some of these problems? Does this kind of ring a bell? Now, go ahead and please shout out, is there any issues or problems with going to the cloud that you have that I didn't just mention? Cool, we're going to solve all your problems today in 3 short steps. Okay. Everybody's here. Sorry, you want to read that slide? All right. Now, I usually say, well, you can download these slides later as a reference, but to be honest, I want to talk to you more today than just provide a bunch of gunk you're going to be able to download later. What's the problem with cloud stuff? Why are we having issues moving to the cloud? Data center locations is one of them. Now, if you think about the public cloud providers, now obviously we're not too worried about private cloud data center locations because it's in your data center. You own that. There's lots of private cloud sessions here in the IT Pro Track. We're more interested in the tricky stuff. But if you look at the major cloud providers right now, let's say Google, Amazon, Salesforce, and us, where are the data centers located? Overseas. They are somewhere else. So this presents an issue. The first thing your C-level execs or EL execs or whatever you want to call them in your particular organization, they say, well, I don't want our data or my data to go overseas. I might lose control of it. You might. We need to look at that. How do we deal with that and why? Right? Corporate policy. You'll find that there are a few bits of regulatory compliance you'll have to deal with. Most of them in Australia revolve around the Privacy Act. Okay? You are the data custodians of any citizen-related data that you deal with. Now, a little more recently than the Privacy Act, you've got the Freedom of Information stuff going on. So not only do you have to protect and keep it secret, but you have to be able to produce that data on request. So people start getting the idea that if that data is located overseas, am I going to be able to do that? We have to address being able to do that. Okay? If you can't, there's no point in looking at cloud, at least not until there's some cloud data centers in country. The Patriot Act. How many people are worried about the Patriot Act? How many of you realize that a lot of data residing in Australia has been subject to the Patriot Act for the past 10 years? You're already dealing with it. It doesn't matter if the data is located in Australia. If it deals with U.S. citizens or deals with a U.S.-based company, it is subject to the Patriot Act rules and regulations. Okay? EU Safe Harbor isn't quite as much of an issue for Australia because we really haven't signed on to the EU Safe Harbor stuff. But I think it'll probably be a short trip before we do. It's something that we're going to have to do, right? Does anybody here not know what the Patriot Act is? September, 2001, trade centers problem. The U.S. government enacted legislation that says it is allowed to access data stored on servers of anything relating to U.S. interests. It's a very broad, sweeping broom that they painted the world with. The allies to the United States pretty much said, yep, okay, you can do that. For better or worse, love it or hate it, the U.S. is the big gorilla. And a lot of countries will pony up to that. So that's why the Patriot Act has this stuff hanging everywhere. So data custodianship. Why do you care about data custodianship? Why do you care about it? Good. This will be because you can be sued. That's the bottom line, isn't it? If you cough up data of an Australian citizen, you have to notify them and they can actually sue you for breach of confidentiality. You, being the data custodian, have to pay attention to that very closely. For example, you guys know the blue bins. You put the confidential stuff in, they're locked, and you're not supposed to be able to get it out, and it's, for shredding. There's a truck going from Sydney to Canberra that is supposed to take those blue bins to be destroyed, or the stuff in them to be destroyed. Some of the bins fell off the truck and broke open and scattered documents all over the Hume Highway. Now, these were things like Telstra bills, ATO tax returns, and what was the other one? I think it was Medicare, I think was the other one. Who do you think got in trouble for that? It wasn't the Blue Bin Company. It was the organizations responsible for the data. Okay? So if you collect data on Australian citizens, you become the data custodian, you fall under Privacy Act and regulatory compliance. Okay? Did anybody go to the session upstairs earlier this afternoon about the regulation landscape and stuff? No? Okay. Well, then that's a moot point. Oh, FUD. Fear, uncertainty, and doubt. How many of you fall into the FUD category? Fear, uncertainty, and doubt. A couple of you? Yeah. I don't know where it's going. I don't know how to get it. I don't know where it is. I don't know what to do, if something goes wrong. We need to address that. And that's what we're going to look at. How we can architect systems and applications to deal with these problems. So, the regulatory body chess match. I'm going to ask for your forgiveness in advance in case I go into a coughing fit of epilepsy or something here. How many of you have read these papers or looked at their policy papers? I think I can count you on one hand. Okay. You guys know what AGIRMO is? The Australian Government Information Management Organization, the section of the Department of Finance. They put out a position paper that said, well, cloud is here, it's cool, but we're not sure if you should do it or not. So what we want you to do as government organizations is go out there and try it and tell us what your experience was like So we can help form that into a whole-of-government approach. So they didn't say you cannot do it, but they didn't say you should do it. They said, do your own risk analysis and tell us what you think. Fair enough. Defense and DSD came out with a recommendation paper. Now these three organizations had this chess match going on, where one feeds into the other and they kind of see how the others are positioning themselves so they can all make these bold, sweeping statements to set the course for whole of government and be the one to lead the way without totally screwing over the other, which is kind of ironic. Defense and DSD put out this recommendation paper, and the key line that most people pick up in this paper was, we do not recommend that you store your data with a cloud provider that does not host the data on Australian shores. Okay? Makes sense. But they didn't say you can't do it. Later in the paper, they go on to say you should use a proper risk analysis approach for doing this. So it's not about can or can't, it's about the risk appetite of your organization. How many of you work in risk-averse organizations? Is there anyone that works in an I don't care organization? Okay. So this is probably going to resonate with some of you, right? Then the Attorney General's office put out their policy paper. And their official policy was that you can do it if you do a proper risk analysis and accept the risks involved. So you see where this is going, right? They're going very much towards a banking model where you can do this if you accept the risk. Now, previously, they were very much about prescriptive guidance. You shall and shall not, can and cannot. They're getting away from that. They just want to make sure you understand the risks you're undertaking. So, that means you can go ahead and do these things, but you need to educate yourselves and your organizations. Okay? Here we go. Now, you don't need to read all these. Well, you can if you want to. Gartner put out a paper a while ago saying, here are the risks with moving to cloud or taking advantage of cloud. And if you look at them, they're things you deal with already. Privileged user access, regulatory compliance, data location, data segregation, recovery, investigative support, and long-term viability of your providers. Of course, long-term viability, that may not be one you're dealing with directly because you always hope your organization will continue to exist, right? But these are things you already deal with. How many of you don't have to worry about regulatory compliance of any sort? Good, you've been listening. Excellent. How many of you deal with data segregation? Classified versus unclassified, highly protected versus protected? Well, anybody who works with government should raise their hand, basically, right? So this isn't foreign territory. When you architect applications to take advantage of cloud-based services, you still need to think about these things. But you don't need to think about them in some weird, freaky new way. It's going to be very familiar with the way you're doing things. Now, data recovery is a hard one, isn't it? Now, you probably have tape backups. You may have off-site backups. You may even have a hot site for failover redundancy in case you need to recover quickly or whatever the case may be. How many of you kind of wonder that if I've got all my data stored in the cloud, how do I do data recovery? Have you thought about that? Have any of you looked at some of the data storage systems that are out there for cloud providers? If you look at ours, for example, we've got two basic flavors. We've got Azure Storage, which is blobs, queues, table storage. And then we've got SQL Azure. Okay? Blobs are binary objects that your applications may be storing right now. You're storing them on local disk, on a SAN, right? Everybody is familiar with databases, SQL Server. The data you're storing now is going to look the same when you store it in the cloud. Your data formats won't change with Azure, okay? SQL Azure or Azure Storage. Not all cloud providers are like that. If you look at some of them, they will take your data, they will change its format to suit their engines that they use for your data. So the search engine that shall not be named will take your data and they convert it to a format that their advertising machine understands how to crawl. In order to get your data back from them, you have to put in a request with their help desk, which they'll process and get back to you once they can, if they can, convert it back to its original format. Okay. Now you can still access your data through their mechanisms, right, through their APIs and stuff, but they can't just say, here's a disk or here's a blob, here you go. Like with SQL Azure, you can just extract the table data like with a normal SQL call, like you would any other SQL database. Look at these things when you're planning your architectures. When you're planning your apps, think about how you can extract the data. If you look at the Azure Data Market, for example, all the data stored in the Azure Data Market has got an OData layer over the top of it. So if you understand OData, you can always get your data back in a normalized format that you understand. So data recovery can be a big one. Now, there is no one-size-fits-all. There is no all in the cloud or all local system that you have to deal with. And this question seems to come up quite a bit. It seems like somehow people have gotten the impression that if you do something with cloud computing, you pick up everything, lock, stock, and barrel, you drop it in the cloud, you turn off everything in your data center, and now you're in the cloud. That's not it, at least with us. I was at a government and technology forum in Canberra about 3 months ago, and one of the C-level execs from Google Australia was in there. It was kind of funny. He was actually on stage, and he said, there is no such thing as private cloud. You should move everything into public cloud, and we're here to help you. Then he just walked off the stage. I'm like, dude, this is a government conference. I don't think you understand your audience. Do any of you who work in or with government think that you could pick everything up, throw it in a public cloud, and get away with it? Not on your life, right? Then there's the other side of the coin, where you can do private cloud. And if you want to do entire private cloud setups, that's fine, but you're not going to get quite as much cost savings. It'll be somewhere in the middle between fully scaled out, on-metal systems and virtualized. With us, we figure it's got to be a mix and match. You have to be able to do stuff in the cloud, on-premise, vice versa, whatever works for you, right? So this is why we've come up with this hybrid model. Now, the hybrid model is where you can have some stuff local, some stuff in the cloud, some stuff in somebody else's cloud, some stuff in a private cloud, and they all work together, right? This allows you to separate the pieces of the app that make sense and put them where they make sense. And that's what we're going to get into, is how these architectures work. So how do we address this? Note for the wise, I just gave you a hint. Now, for any of this to work, in order for you to do data protection, taking advantage of cloud services, you have to have a data classification scheme. The reason you have to have a data classification scheme is because if you don't know what you can and cannot send offshore, or the protection levels you need to apply to a piece of data, there's no way in hell you're going to be able to protect it. If something is classified HP, highly protected, you know what you have to do with it. You know who can have access to that data. You know they have to have a security clearance, right? You have to have an HP clearance to access the data. Now, in our case with Azure, our administrators for the Azure system do not have access to the local data on a normal basis. They can help you extract data if you've had a catastrophic failure of something. They can try to help you recover it, but you will have to go and get it. Our data centers are set up I kind of like the way they're set up with my security background, right? The people at the data center cannot access the servers. The servers are locked in these cabinets, and they cannot access them. They're always dealt with from a remote site. The administrators of the servers do not have physical access to them. So we've done the separation of privilege thing pretty severely, right? I think that's a good plan. So make sure you know how that system's going to work, right? So the administrators that you talk to, you can't walk in to a public cloud, okay, somebody say it for me, public cloud provider, and say, this is the disk my stuff is on. This is the rack my servers are in. You can't do it. There's two reasons you can't do it. One is security. The other one is, it's going to be distributed across the whole plethora of systems in there, right? Because it's done that way, you have to know what kind of data you can put there and what you can't. So start with data classification. If you don't do this, I guarantee something will get past you. You will end up putting some piece of data in the cloud that you probably shouldn't have. Okay? Or, flip side of the coin, is you'll be so conservative with everything, you won't get the full advantage out of the cloud computing, the cost savings and benefits. Okay? So we've got to find the middle ground. That rule of thumb at the bottom, this is just from my experience with Canberra government, public sector. If it's highly protected, below highly protected, you can probably put it in the cloud. If it's got an HP rating, I'd think twice before putting it in the public cloud. Use a private cloud or use a community cloud, or it's sometimes called a G cloud, a government cloud. Right? Now, topologies. So we call this code near, code far, and hybrid. Now, a code near basically means everything is close together and put in the cloud. Data storage, application logic, UI is all in the cloud, so everything's very close together. Benefits, you have no infrastructure to worry about. You have nothing to patch. You don't worry about depreciation on your hardware. You don't have to worry about lead times. If you create a new project, there's no hardware lead time, right? It's also very fast. The really fat pipes between the Azure servers and the SQL Azure servers will transmit data very, very quickly. Excuse me. Drawback, everything is in the cloud. All of your data has to be in that scenario, has to be up in the cloud. So if you've got HP data, that's not going to work for you. You simply can't do it. So we go a little bit further, and we have this code far idea. The code far idea, and this can be flipped over with either the, one or the other in the cloud. But this is where you take advantage of SQL Azure or the Azure Data Market, but all your code is local. Local servers, local machines, and you're using OData and web services to extract the data from the cloud provider. This works really well for massive data scalability. If you've got a bunch of stuff you want to put up in a database, you can do this. An example of this is the Genome Project. The Genome Project is hosted mostly in the Azure Data Market. Massive scalability, massive availability. Anybody that they want to allow access to it can get to that piece of data and start chewing through some Genome Project stuff. Okay? This is where people like the Square Kilometer Array would put their data up there. Big data sets, a lot of research data sets. This works fine for them. In the keynote, you heard about the factoring, prime number thingy. This system would work well for that. Big data set in the cloud, you extract a little, do your number crunching, send your piece back up in the cloud. SETI project. Now the last one. This is the key right here. This is the one that'll get you over the line. The hybrid model. This is where there's different combinations of data and code, local or in the cloud. Ideally, what you want to do is keep all of your not yet classified or HP and above data local, in a local database. Send your unclassified or low classification data into the cloud, keep it near the code. App code and tools can be in both places. If there's something that has to access a secure piece of data to do some kind of calculation, it can call back into your infrastructure on a web service call to facilitate that. So you can still have that functionality. And we're going to talk about this one in detail. So it's this combination of on-premise and cloud-based stuff. Now, how many of you went to the SharePoint to or Azure to Office 365, SharePoint and Office 365, or Azure and on-premise data presentations today? Okay, you've already seen hybrid architectures in action. Those are all examples of hybrid architectures. In this picture, we show cloud to on-premises. You can do cloud to cloud, cloud to web service, cloud to business partner, right? Where things are separated, this stuff works. Now, the SQL Azure Data Sync can be a key part of this. Imagine a scenario where you can take a cloud system, you have your main database on premises. Someone has to classify the data. Once the data has been classified, it can then be sent through a view of unclassified data. That view can be synchronized to a SQL Azure database in the cloud or blob storage or whatever the case may be to allow you access to that data in the cloud. How many of you deal with government-to-citizen initiatives or anything like that? A couple of you? This is where you're going to want to be able to provide data to the citizens. This is a really common example of where organizations like the ABS, the Bureau of Statistics, will take data, sanitize it, or clean it up, and then make the sanitized data available to the general public. It's a really easy system when you're using the SQL Azure Sync. Now, one of the things that I like about this is that it's incredibly flexible. You can move all or some of your UI and business logic into the cloud. Okay? Let's look at a little bit more. So some common deployments. This one is probably the easiest to pull off. Okay? This is where you're taking your UI components and you're moving them into the cloud, but all the business logic, the tricky stuff, the secure services, and the secure data is kept on premises. In this kind of a scenario, what you do is you enable people to access your systems as normal, but the key is they're no longer touching your network. How many of you have seen hacking presentations? A few of you? What do the bad guys do? They start off on one of your web servers. Now, we're not talking about malicious insiders, right? They start off on one of your web servers. They find a vulnerable application on that web server. They establish an account or they upload a file to it that they can then blossom from, create their own accounts, and they use that machine to hop through your network, attacking the rest of the machines in your network. Keeping the unwashed masses off of your infrastructure is one of the easiest ways to prevent your internal systems from being hacked. Don't let outsiders touch them. The U.S. Department of Defense is recommending this approach for defense organizations. Keep your UI off of your infrastructure, at a minimum, the UI. Okay? The web services at the business layer can still be hosted on premises. Now, these web services can be either like WS Star-based web services, or you can work over something called Azure Connect, which we'll cover in a little bit, right? How many of you have business-to-business web services available or something like that? A couple of you? Those can still stay right where they are. If you've done service-oriented architecture in the past, chances are your UI layers are already used to calling over some kind of a service bus or some kind of web service call back to this business layer system. So chances are moving that out to the cloud isn't going to be that big of a deal. Now, of course, there's all the caveats around that. When you do this, you do expose stuff because you have to have this opening in your system. If you're already exposing your web services to outside organizations, chances are those firewall holes and those access points are already there. The difference is now it's your stuff that will be coming through the same channel. So obviously, authentication is going to be critical on these things. Okay? This is really good for applications that have a low back-end support thing. One of the things that's going to be the theme across all of the hybrid architectures is chunky communications, not chatty communications. Okay? I'm going to explain that in the challenges section in detail, right? What you want to look at. Okay, so this is the basic first step. The next step, we move a little more into the cloud. In this case, the UI and the business logic are in the cloud, referencing an on-premise database. Okay. With these, you get a pretty good economy of scale here. All of your kind of CPU-bound and services stuff is in the cloud where you've got internet scale capability, and you get the most bang for your buck as far as cost savings goes over on-premise infrastructure. Right? You still handle the SAN and the data storage locally. This can be exactly what you need. Some people don't have to go any further than this, right? Again, now you get the bad guys, end users, and network service calls off your network. Okay? So if someone has compromised a business partner and they launch an attack from that business partner, it's in an isolated server in the cloud. It's no longer on your infrastructure. Okay? It doesn't happen quite as often as, say, the interactive hackers, but it does happen. Ask TJ Maxx. Have any questions about that so far? I'm just kind of rattling. I'm sure you'll all go, if you have one, right? Okay. Stay awake now. We're almost there. Now, this is really good for situations that do form filing. If you have applications where people are filling out forms online and sending them to a local database, this is a really good setup. Because all of your data validation and a lot of calculations can still be done in the cloud before the stuff is packaged up and sent back to your local database. This way, your database only has to deal with stuff that's going to make sense to it. Okay. Now, this is the one I prefer. It offers the most advantages when it comes to being able to segregate data. You can take your unclassified or low classified data and put it out there, and static data, of course, static data. You can get it out there where the only thing that's going to call back to your local system now are known, highly classified or highly secure communications. You can authenticate the crap out of them, right? There shouldn't be very many of them either. The more stuff you move to the cloud, the fewer communications come back into your organization. How many of you in here are IT security admin types? A couple of you? That's a good thing, right? The fewer communications that have to come inbound to your network, the better off you are. Okay? So obviously moving everything into the cloud eliminates all of them. Not always practical. Now, if you move your business layer and stuff into the cloud, there's no reason for your business partners to have to change. You can use the same URL in the cloud that they're calling you now with. It's just that it means it's going to go to a different server. And then you get that internet scale expandability that you need. Excuse me. Good for unclassified data. Or, yeah, unclassified. Not yet to be classified. So, how does this help security? Well, at the moment, it provides excellent DDoS protection. How many of you think that you have a better DDoS protection than major cloud providers? Anybody want to take a stab at that?
Is the flip side that you're a target and I'm not?
Is the flip side that we're a target and you're not? Absolutely. Security by obscurity can work that way. Now, if you have highly sensitive data or high-value data, they're going to come after you wherever you are, right? If you're a government organization, if you're, the Sony PlayStation Network, you're a known target. Doesn't matter where you host this stuff. They're going to come after you wherever you live. So if you're not worried about it, though, and if you're at a point where the obscurity is working for you, if it's not broke, don't fix it. Right? The DDoS protection that we have in place, we've been practicing and fine-tuning for almost 15 years. We've been doing cloud-based services for just over 15 years now, since Hotmail came into being, right? So we've had a lot of practice at this. Now, every time I say this, somebody brings up an incident, but if you look at Microsoft.com, www.microsoft.com, it hasn't gone offline yet, right? Now, I'm not talking about a couple weirdities, but Microsoft.com has not gone offline. Microsoft.com is attacked more than any other website in the world except the U.S. Department of Defense, for some odd reason. We get attacked on Microsoft.com over 7,000 times a second, 24/7. We get DDoSed all the time, right? Our Azure infrastructure has more capability to fend off a DDoS than Microsoft.com does. So we've got pretty good DDoS protection out there. Now, that's not going to prevent script kiddies from trying to take down the core internet routers. That's something we can't stop. Keeps the bad guys off your network infrastructure. Any hacking presentation you go to in the world is going to show you how someone can compromise a server, use that as a launching point to compromise other servers attached to this network. It keeps them from being able to compromise your machines, right? Now, there's an application level security issue that cloud computing will not fix for you. Cloud computing will not stop SQL injection. However, in SQL Azure, SQL injection attacks are severely mitigated, kind of by the nature of SQL Azure. For example, there is no XP command shell in SQL Azure. Doesn't exist. There is no operating system calls in SQL Azure. So the worst they can do is jack up your tables and your data. Not that that's not a bad thing. I mean, not to belittle the point, but there isn't going to be a server compromise. Okay? This allows you to keep your classified data in your own data center where you're comfortable with it. If you don't trust a cloud provider with the highly protected data, that's fine. Don't put it all in the cloud. Keep it local, keep it secret, keep it safe. Right? How many of you know where that's from? We got to geek out a little bit, right? If you don't know, you need to do some movie watching. It limits inbound connections to a single, well-validated source, especially if you're using Azure Connect as a communications channel. Okay? So, all in all, this is a pretty good security scenario. It mitigates a lot of the risks and problems you're facing when you're hosting your own infrastructure. Okay? So, instead of thinking as cloud as an all-or-nothing deal where we're exposing ourselves to a lot more risk, think of it as a tool you can use to mitigate some of these risks, right? So, Azure Connect. Azure Connect is, how many of you've heard of it already? Okay, not enough. Azure Connect is a system where it's kind of like a virtual IP network where you can connect your systems to cloud-based systems and you can access them over an IP-based protocol, right? You can use AD authentication over Azure Connect, ADFS. Everything works as if it was on your local network. Now, for some reason, people have gotten the idea that Azure Connect is connecting your network to the internet. That's not what it is. Azure Connect goes from instances, web roles, worker roles specifically, to specific servers or server groups in your network. It is not opening up your network to the internet. Okay? So, yeah, the dotted lines in the boxes, these are in groups. They're server groups. So sometimes you don't want to go role to role or role to server. It makes more sense to do, for load balancing purposes, to do a group of roles to a group of servers. So then they can all communicate together without setting up individual tunnels between each one. Azure Connect is an IPv6 IPsec tunnel. Point-to-point secure authentication, mutual authentication. It's a well-known, well-understood certificate-based authentication mechanism. Excuse me. It goes a little further than WS Star standards, right? And it makes it a lot easier to communicate with your cloud-based systems. Admittedly, Azure Connect only works with Azure. You can't do Azure Connect to Google or Amazon or Salesforce or something like that for obvious reasons. Okay? It allows remote administration of your Azure applications because now it's IP-based traffic, TCP/IP-based traffic between you and your Azure-based applications. So SCOM or System Center, it all works. You manage your cloud-based applications just like you manage your on-premise applications. Same console, they all look the same. So you don't have to go through any weird hoops to be able to manage it. Okay? And it's simple setup and management. You set up there's a little agent you install on the local on-premises machines. You don't even have to have IPv6 enabled on your system. It'll create an IPv6 stack, configure it, and communicate to the worker or web roles that you designate in the cloud. So it handles all the plumbing for you. You just have to tell it where each piece, where the endpoints are that you want to connect to. Does web worker and VM roles. It supports all the different roles we have in Azure. And it can connect to anything on-premise that you install the agent on for whatever purpose. If you wanted to put it on developer workstation so they can call a developer web service, go ahead, but don't call me when it goes wrong. Because developers will make it go wrong. I have a developer background. I empathize. So the challenges, and there are a couple. We already kind of covered one, latency. I didn't know that was a build. Okay. If you have a system that is constantly pinging another service or constantly talking to another server or database, when you stretch that connection between the two, latency is multiplied. Microsoft Research is working on a way to increase the speed of light. However, Einstein died, and we're having trouble with that one. It's something that everybody's going to have to deal with. And having data centers outside of Australia doesn't help. Closest Azure data center is Singapore. Okay? Now, fair enough, it's pretty quick. We've done some demos over it, and we have one of the medical demos where they transmit X-ray images, a couple gigabytes. It can do it in a couple seconds, right, with all the right switches turned on. But there's still latency. And every time you make one of those calls, you take that latency tax. Okay? So, think big chunky conversations. Big message down, big batch of data up. Limit the amount of times you have to go over the network. That is standard architecture 101. That shouldn't be new to anybody. Okay? Between web roles and SQL Azure, that's going to be pretty low latency, because unless you say, put my web role in Singapore and put my database in Dallas, that's not so good, right? Think when you're doing this. Now, the cool thing about cloud applications is you can distribute them around the world. You can say, I'm going to serve Australian citizens wherever they are, if you work with Austrade or something. And then you can put databases, one in Ireland, one in Dallas, one in Singapore, one in Bay Area. And you can also put your application there as well. So let's say you want to expand into a new market. You're Australia-based right now. If you're using public cloud, you're based in Singapore, but you want to expand to the US market. So you drop some stuff into Dallas or Bay Area, and you serve your US customers out of that system. Now, in a hybrid scenario, if it has to communicate with a database you're keeping on premises, that's a long trip, isn't it? So whenever possible, cache data as far forward as you can. Obviously, I'm not going to say this too many more times. Highly protected data doesn't count. Unclassified, right? The data you can send. The App Fabric caching system, which was released a couple months ago, will help you with this. If you use the App Fabric caching system, it'll prevent you from having to do all these calls back to SQL Azure. Okay? Now again, in SQL Azure, you're probably going to have the data and the information that's unclassified anyway. The Azure App Fabric caching system could help you with data you want to pull out of a local database that might be highly protected. I don't recommend it. If it's highly protected data, you use it once and you scrub it. You don't leave it hanging around in anybody's cloud, right? So don't put HP data in the caching service. Okay? And then blob storage in the content delivery network. If you have static data, any static data, images, HTML, PDFs, anything that's not going to change, use this content delivery network. The content delivery network is like 22 different locations around the world that we have, including Sydney. We have a CDN in Sydney. So if you have static data, take advantage of that. It will preload. Like if you get a lot of traffic from Australia, the system will realize that, and it'll forward cache the static pieces of data in Sydney to allow quicker access for people in Australia. If you set it up to do round-the-world service, as the lights come on in Ireland, it'll start forward caching data in Dublin for that purpose. Okay? Take advantage of the content delivery network whenever latency may be an issue. Here's where the locations are, right? Seattle, Bay Area, LA, San Antonio, Miami. Sorry. and Sydney AU, the one that makes sense to us, right? Oh, something I forgot to mention. When you're talking about cloud providers and cloud service providers and all this stuff, ask them where they back up your systems to, right? If we hosted your system in Singapore, but our emergency recovery was in Beijing, we have a problem, right? Totally different set of rules apply to hosting stuff in Beijing, for example. Okay? So check where that is. In the case of Singapore, the backup is Hong Kong. Now people go, isn't that China? Almost. Hong Kong is a special administrative region. It is still effectively like it was before the British left. And China basically said, hey, that thing works. Let's leave it alone. Right? Money comes in from Hong Kong. We don't want to mess with it. So Hong Kong has rules that are more similar to Singapore, which is why we chose that instead of someplace like Shanghai. Okay. So you see that the distribution of the CDN is a lot better than the Azure places themselves. So you're able to forward cache data a lot closer to where the customers are accessing it from. Okay. Sorry, those of you in Perth, you got to live with it. Now, another one. Is there any questions about latency or forward caching? Pretty clear? Pretty much Architecture 101, right? System dependencies is another one that you're going to have to address when you go into these hybrid architectures. Legacy systems like mainframes or mid-range service buses or something, you're not going to move the mainframe to the cloud. If you have to make a lot of calls back into a mainframe system, you're going to have issues because, again, you're starting to get into a chatty conversation. So what you may need to do is create kind of a bus system that will hopefully be able to cache some calls from a mainframe or pull that forward a bit or change the structure of it so that they're chunky conversations, not chatty conversations. Okay? Think about stuff like that. And pretty much any internal service you have that's like that. You probably have a lot of internal web services and things that are on a service-oriented architecture. Every call is going to incur that latency. So think about trying to cache it or turn them into chunky conversations or even use asynchronous message type queuing if you can do it. Now, real-time systems, you're not going to monitor a nuclear power plant from the cloud. Okay? Look what happened in Japan. Too early? It's too early for that, isn't it? Sorry. Too soon. But the cloud was never intended for that. The cloud was intended for people like Domino's Pizza. Right? Domino's Pizza is a great example of being able to take advantage of internet scale capability while using a hybrid application. American Express does a hybrid application. Screw them. Let's talk about Domino's. I like pizza. Domino's Pizza takes more orders one day a year than the rest of the year combined. What was it? Excellent. Did the accent give it away? No. Super Bowl Sunday. Super Bowl Sunday, in 4 to 4.5 hours, they take more orders for pizzas than the rest of the year combined. So what they do is about an hour before the Super Bowl, they go into their Azure account and they spin up just over 500 servers. 20 minutes later, they have 500 servers available to them. Those servers take the UI and incoming orders and feed them to the local restaurants to their on-premise database systems. About an hour after the Super Bowl, they go in there and turn them all off. They only use them one day a year in a hybrid scenario to handle a massive scalability issue. Now, granted, they're not handling a lot of secure data. But Super Bowl Sunday is also when they get more attacks than any other day of the year. And when you move those attacks into Azure, they don't get DDoSed anymore. When they have dropped a server, it's contained in the Azure bubble model. There's 12 layers of security wrapped around an instance in Azure to prevent anything from getting outside of it. And that server comes back up within a minute, cleaned up. Right? Instant redundancy and failover. So these are the kind of things you can take advantage of. Do any of you work in that kind of a peaky scenario? Doer, ATO, some of those, where like online tax filing, one day a year, right? And it's like midnight of that day. Everybody files them all at once, right? Or Doer, once a quarter, they get all of these applications for grants. Turn them on, take care of the information, turn them back off. Australian Electoral Commission. Anybody in here from AEC? Is Tim Courtney in here? Okay, good. No, I like Tim. I used to work with him. He's a good guy. They have had situations where they have servers that they've commissioned, installed, and decommissioned before they've been turned on because there's a span between elections, right? That's a waste of money. But they can take advantage of hybrid scenarios by putting the UI and the virtual election tally room, whatever that thing's called, in the cloud. Handle all the incoming requests for the tallies that are coming out in the cloud while the data is being pulled from their on-premise database. Okay? Comes in, they do their sanitization, gets put in the public record, and served from the cloud. Right? If there's any systems you have that have to stay on-premise for compliance reasons, you're going to have to talk to them over the wire. Can't get away from that. The unsanitized electoral data, personal data, tax records, you're not going to be able to get away from that. So just watch the communications and what you're calling. I'll put this up here. Kind of makes sense, right? So you might have a web role going through the service bus, talking to a local on-premise system that communicates with the mainframe, or a couple web roles going through Windows Azure Connect. Same system. Using Windows Azure Connect to let the web-based or the cloud-based systems connect to your existing SOA, and then talk back to the mainframes. It's just a different angle they come in on. Okay? It's configuration. Another one, authentication and authorization. How many of you use built-in AD authentication now for your apps? It's easy, isn't it? It just works. That's an AD. You use AD authentication. Already dealt with you once. Here's your token. It works. This is good, but right now you're going to need to use Azure Connect to enable that. So if you do, you can do AD authentication with your cloud-based systems, providing that they can get to your Active Directory or a DC through Azure Connect. Don't put your domain controller in your DMZ and expose it to the internet. Okay? If you do, I'm going to have it for lunch. Right? Federated identity. Anybody using ADFS yet? Active Directory Federation Services? Slick? Yes. It's very slick, isn't it? You get a token, SAML-based, standards-based. That token's good, and anybody that understands SAML, which is most things now. Another thing we've got is I should probably put the picture on the screen for you. Blah, 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 blah. Oh, back up. OAuth, Open Authentication Protocols. The Azure Access Control Service is based on OAuth. Okay? So it already understands open authentication protocols, like signing into Google, Facebook, or Twitter. It understands those tokens. Okay? So if you want to reach a new customer base and expand your customer base, but you don't want to have them create an account with your system, so that's okay. Sign in with Twitter. Sign in with your OAuth provider, and we'll accept that. It's all certificate-based. Okay? So you can have an ASP.NET membership database. The web role can talk to that database. I have the arrow in the wrong spot. Then the web role can communicate through ADFS back to Active Directory. Obviously, that requires a trust from ADFS to the web role, which is easy to set up via certificates. Now, this is a 200-level session. I'm not going to go deep dive into how to set this up, but I'll be around later if you want to talk about this kind of stuff. Or you can go through the Access Control Service. Now, the Access Control Service, the web role can present this, it's called an OAuth wrap token, Web Resource Access Protocol token. The ACS will convert it to an ADFS token signed by your server, and then you'll validate that for authentication. So there's a lot of different ways you can do this to facilitate strong authentication to people coming to your web UIs, web roles. Access Control Service can also accept Yahoo, Google, Passport, Facebook, whatever that complies with OAuth, it'll accept. Large databases. Now this has been a bit of a bugbear. Yeah, let's do a hybrid app. We'll put all of our unclassified data in the cloud. It just so happens we've got 85 billion terabytes of data. Okay, maybe not. The upload alone will take you 4 years, right? So we previously had this problem where the SQL Server databases were limited to less than 50 gig. Help is on the way. That's going to be changing. And that's all I'm allowed to say about that. Ways we could do it, you can do, here, let me get these on the screen. You can do different ways to facilitate that. You can shard your SQL Azure databases. You can split up databases into different regions, regionalize them, split up the data however makes sense for your organization, and then use multiple SQL databases. Or use blob and table storage. Blob and table storage is huge, humongous, right? And we found that table storage, anybody know what table storage is? Table storage is not relational storage, it's key value pairs. It's, for those developers in the room, it's more like a dictionary object. You have a key and you have some piece of data that relates to it. And those pieces of data don't have to be the same. In row 0, you can have an image, row 2, you can have a XML file, whatever. It's incredibly fast. The table storage system is incredibly fast. The Azure Access Control System is based on the Azure Table Service. Really slick. Okay? So you can use these mechanisms instead when you're coming across large data in the cloud. Management and operations. When you think about it, one of the huge benefits to moving to cloud is that you no longer have to screw with the machines. No setup, no teardown, no lead time, no patching. How many of you like patching? You would. That all goes away. And that's a very attractive system for a lot of IT departments, right? If we can get rid of the patching load on the IT departments, they can worry about the important stuff, new configurations, new apps, managing the AD infrastructure and stuff that makes sense, rather than dealing with Patch Tuesday. But our involvement and our ability to save you from yourselves stops at your code. We cannot get into your code and troubleshoot it for you. We can provide logs, we can provide some analysis, we can provide some help, but you are still responsible for your applications. Developers? Oh, you sneaky. Okay. For a second, I thought you were all going to hide. Well, not me. It's still on your shoulders. Application breaches are still the #1 weak point for IT. Right? You don't see too many OS attacks anymore unless you have an Android phone. Okay? Had to be said. Oh, we're recording this. Oh, no, we're not. The camera guy's gone. Good. So, how do you monitor performance and troubleshoot errors? System Center. You put an Azure Connect system in there, and System Center will work just like it does with all your other apps. Okay? In the web roles and worker roles, you can put traces, listeners in there, developers, enterprise library, trace listeners and log files. That all works. Okay? You can do these. You can do automatic log sending. You can even take your logs and have them sent back to an on-premises thing for analysis if you want. Okay. You can use remote desktop to get to the IIS web roles, IIS VM roles. Right? You can look at those. You can do table and blob storage. Save these off. Save your trace listeners and your log files off to a table or blob storage, and then have a worker role that monitors them and fires off alarms if something goes funny. Visual Studio, you can look at these things in Visual Studio. System Center Operations Manager works with your Azure applications. Okay? Now that's stuff that your IT departments are used to using now. Well, at least I hope they're used to using it now. There's been a bunch of third-party tools created for it. Several of them PowerShell-based. In fact, we've been releasing packages of PowerShell scripts that'll help you do things. The coolest one, I think, is it monitors your web and worker roles, and as the load gets above, insert number here, say 70%, it'll spin up another couple roles for you. So it keeps the load balanced between like 50 and 60%. And as it dies off, it shuts them down. Very cool. Okay. Some technical considerations. Right on time. Which applications are easiest to migrate? Now, there's going to be some changes. The big thing about Azure, or any cloud provider really, is you start getting limited to the types of interactions you can have with the OS. SQL Azure is a great example. All the T-SQL stuff you know that makes operating system calls will not work in SQL Azure. If you're using .NET stuff where you're accessing the file system or local drives, you can have a mapped drive over blob storage, but it's the first VM or first role that gets a hold of the mapped drive is the only one that has write access. All the rest are read. which is why you don't install SharePoint in a web role yet. Okay? There's other ways to deal with that. I should say that people have done it, but we don't support it. Kind of favor applications that have web service interfaces. They're kind of self-contained. They're designed for the web. They do form processing. You're not going to put something that monitors the operating system in Azure because you don't want to monitor Azure. You want to monitor your stuff, right? Look for stuff that's predominantly custom code. If you're calling out to a lot of other libraries or a lot of other on-premise systems, all that has to be available to the system in the cloud. So measure how much you're going to put up there and if it's worth it. Now, there's nothing stopping you. If you're using ChartFX and Enterprise Library and all these other things, you can move them up there. They'll work fine. Right? Don't depend on a durable state, at least not yet. I think you've seen in our roadmap. Anybody seen the roadmap discussions around Azure? No? Okay. We're moving towards a persistent VM image, so you have durable state. Right now, that doesn't exist. So if you're storing session data, for example, if that VM falls over or something happens to it and has to be recycled, all that goes away. So you can't always depend on durable state being there. Avoid thick client applications, right? For obvious reasons. You don't have a thick client. Okay? Now, one of the things that's really cool is you can take thick client apps and have them call out to Azure-based services or web-based services. One of my favorite paradigms with architecting applications is a cloud-based service and device-independent delivery. Doesn't matter what device you bring to the table, the UI or the local app can call a cloud-based service for the meat of the data or the stuff you need to do. And this is where the future is going to go. HTML5, Silverlight apps, all that stuff is going to be calling cloud-based services. Avoid applications that are leveraging like COTS products because you can't install product X in the cloud lock, stock, and barrel. At least not yet. Okay? And complex network topologies are going to hose you. Okay? Look, we said durable state twice. Hint. So, is the data security better? So we look at the CIA triangle. Confidentiality. If you have cloud-based applications and using hybrid architectures, confidentiality is as good as what you have now, if not better. If your system is exposing data now, your software will probably expose data in the cloud. If you don't have a good data classification good data classification program, and you're not using data separation of privileges, you have the same problem now on-premise that you would in the cloud. Okay, start there. Integrity. It's at least as good as you have not. Good as you have now. Okay? Data integrity is guaranteed by cloud providers. If they couldn't maintain data integrity and data availability, they wouldn't be there. That's their core business. When you put data in Azure, table storage, SQL Azure, whatever, there are always free live copies of it at any time. If one of those goes away, it switches over to a backup copy while another fresh copy is created. We always maintain 3 copies of the data for redundancy, failover, and data integrity. Okay? Now, if your application code does something funny with it and stores it incorrectly, we can't help that. But whatever you store with us, we guarantee its integrity and its availability. This is probably better than what you have now. Our failover scenarios are pretty good. How many of you heard of the Office 365 beta outage in Dublin? They told us not to talk about this, but might as well bring it up. A couple of you did? So there was a lightning strike at the data center in Dublin. The lightning strike was so bad that the feedback pulse on the wires actually blew out the backup generators as well. The whole thing just melted, gone. This data center hosted our stuff, our Office 365 beta, and Amazon's EC2 systems. Our stuff was back online with our failover data center in Amsterdam within 4 hours. Everybody was back up and running within 4 hours. Unfortunately, Amazon's system wasn't quite set up that way. It took them almost 10 days to get everybody back online. So you can imagine they're paying out on their SLAs. Well, at 4-hour outage, we would too. We would pay out on that SLA. So think about that kind of stuff. if you had a lightning strike that took out your data center, its backup generators, and everything else, how soon could you be back up? Within 4 hours? Some of you probably could. If some of you are running hot sites, you probably could. But you'd have to be running a hot site. Judging from some of the government data centers I've seen, right, you'd be in trouble. So availability is critical to a cloud provider, and chances are they're doing it pretty well. We've got ISO 27001, SAS 70, Type 1 and Type 2 attestations. We're doing all the right things. And we're working with ISO and a few other organizations to create standards for cloud providers, specifically for the cloud providers. It's just like the brick and mortar thing. These things didn't exist yet, right? So, got 10 minutes left. Not too bad for questions and answers. Hopefully answers.
You mentioned that using SQL Azure is going to mitigate a lot of the SQL injection attack.
Okay. Yes. So, using SQL Azure will mitigate the damage of a SQL injection attack where it would relate to the operating system or a hopping point, a future takeover. Because the accounts don't exist, the system doesn't exist for them to create their own accounts. Where it doesn't mitigate is where table damage could be done. Table deletion, row deletion, data change. It can't mitigate that because a SQL injection, it would still execute it as a SQL command. But where SQL stops and the operating system begins, all that stuff goes away now. No XP command shell, for example. That make sense? Okay. Anything else? Yep.
So with the Connect,
With the Connect, Azure Connect, not Connect.
we were talking about latency before, and that
Latency.
is obviously going to jump up a little bit as well once you're implementing Connect.
Actually, we found it doesn't do too bad because when you establish Connect, it's a TCP/IP system, and most things are really efficient across TCP/IP now. In fact, I was asking one of the guys this before. They said they haven't actually seen an appreciable difference over Connect versus normal web service calls. So it probably won't increase the latency. I would almost postulate that would help reduce some of it because when you do a normal web service call over the internet, it might get routed to Timbuktu. But over Azure Connect, it'll be a little more direct.
You briefly mentioned SharePoint and Azure. Is SharePoint
Yep.
likely to support that kind of hybrid architecture where perhaps you have some content databases
I-
on-premise?
So the question is, I briefly mentioned SharePoint and Azure. Is SharePoint likely to support a hybrid architecture? Yes, it is. Yeah, in fact, you can do some of it now where SharePoint calls off to a web service. It can do it now. Even SharePoint Online can call off like an Azure web service. There was a session about that this morning, connecting SharePoint to Azure. It's something we're actually very interested in and we're pursuing right now, is enabling more of that. Yep. Yep.
You mentioned that you can monitor your application settings for virtual machines and then customer comes in. I assume there's a cost associated with that. Is there a
Yeah.
way to manage how many machines you have?
Yep. In fact, we're setting up a system now. When we first put up Azure, the question. I mentioned about the automatically spinning up machines and shutting them down. How do you manage cost? What if it just keeps going and growing, and all of a sudden your Azure bill goes out the ceiling? That's problematic. And at first, when we first set up Azure, we did not kill off your applications because availability in your business critical applications, we weren't going to start shutting them off on you. You know, it's better to have to pay a big bill than have something go south. So that's how it was set up. Now you could cap it where you could tell the script if there's already 10 machines running, don't start another one, just deal with the load. But we're introducing a system coming up where you can tell Azure that when my bill reaches a certain point, stop. Now, I wouldn't recommend that for a mission critical application, but you can have it capped. Yeah. You can enable that. What you would find out is all of a sudden it wouldn't be talking to you anymore. Oh, we're not getting any incoming connections. Something must be out of whack. Yeah, because it would just shut them off. Although I would probably set it up so that when that trigger happens, it sends a message back to base saying, we've reached our cap, we're about to shut down this section, and have it divert traffic to an on-premise system, which is scriptable. That whole system is scriptable.
that same risk assessment is going to let me move the application to the cloud, which is going to give you access to the database?
That's kind of a cool question, right? So if the database is local, wouldn't the risk assessment say that the application that accesses it should stay local too, effectively, right? Not necessarily. Because if you're not maintaining a lot of data in memory or in state, then the stuff that's in the cloud doesn't contain any critical data. It pulls it from the database, it delivers it to the user at return from the HTTP request, and then it doesn't have it anymore. So the stuff in the cloud isn't a risk, because that's not where the data is held. It's where the data is held. Now that's why I said before, if you're going to use the caching service, keep the HP data out of the caching service, because now you're putting that data in the cloud. So the application probably is not at risk as long as it's doing the right things and not caching a lot of data. Yep.
But that relies on the trust that you haven't installed something funny on your end.
Fair enough.
Is that covered by your SLAs?
Absolutely. We spell out in several locations in our SLAs that your data is your data, not our data. We don't own it. We don't farm it. We don't look at it. It's your data. It's your responsibility. We're hands off with your data, okay? So when you do that, yeah, it's a matter of trust. Read the SLAs. Read the EULAs. And this isn't like downloading some Flying Pigs game, okay? Make sure you understand it. But that's a good question. It is about trust in the provider, right? So read them. Do any of you guys know the magic number? Speakers, when they're up on stage, they're supposed to count to 8. And if there's no more questions by the time I get to 8, I say, thank you, I'm done, and everybody leaves. So now you're all going to go 1, 2, 3. So I am finished. If there's no more questions, thank you very much. If there are questions, I will hang around because this is like the last session. Please fill out your eval forms. I didn't cough too much, so I think I did all right. The big numbers are good. Big numbers are good, okay? But try to get those Arc Touch mouses. Once you get used to those mice, they're really cool to use once you get used to them. Okay? Thanks.